Welcome to Patterns of Atrocity, the video series where we talk about the interdisciplinary fields of computer science, sociology, and history to model genocide and learn what can be learned about preventing genocide to shape a future free from atrocity. Today we're going to be talking about a simple agent-based model of genocide that even in its simplicity is able to come to some interesting conclusions about the conditions necessary for genocide. First, before we even get into the paper, we should talk about what agent-based modeling actually is. Simply put, agent-based modeling is a computational modeling approach that simulates the actions of individuals within a defined community. These agents follow simple rules and make decisions based on their environment and interactions with other agents, and by observing the resulting system-wide behavior of an agent group or agent groups within an environment, researchers can help understand complex phenomena and uncover emergent patterns in the behavior of the agents and try and relate these patterns to real-world data. The paper we're going to be discussing today is called Modeling Genocide at the System and Agent Levels. And this paper is based on sociological research that tries to understand the way the environment and factors involved in the environment influence the way particular people or groups of people can be inspired to commit genocide. In the image on screen, each arrow indicates that there's an effect from one environmental factor to another, with a positive mark involving a positive correlation, a negative mark indicating a negative correlation, and a positive-negative mark indicating an unknown or unexpected correlation between these two factors. The goal of this paper is to try and model this, or a simplified version of this image, using agent-based modeling. I won't spend too much more time talking about it, but if you're more interested in the sociological research, you can look at the paper that'll be linked at the end of the video. To dive straight into this model uses a simulation of 100 agents, where each agent is given an identity belonging to a group A or a group B. The goal of this model is to simulate situations where either one group will eventually kill the other group, or to come up with a situation where neither groups kill each other and the populations remain the same. Each agent is also defined with 5 other attributes, which I will define after this, which influence the way the agents interact with each other. The first of which is an agent's ideology, used to determine how extreme or divisive an agent's view. The idea here is that the more ideologically bound an agent is, so the higher its ideology value is, the more likely it will be to commit genocide. Next is an agent's influence, which seems fairly self-explanatory, but will be discussed later, is an attempt to influence the way real-world parties or groups are influenced by a leader-type figure. In this agent-based model, the agent of each group with the highest influence will have a profound effect on influencing the behavior of other agents. The next is an agent's susceptibility, influencing how likely an agent is to be swayed to an ideology by another agent. We can kind of see how these agents are starting to look like people or actors of genocide. Each person has sort of an influence, an ideology, or susceptibility that is initialized on a range at the beginning of our model. Next is an agent's threshold to act, which basically determines how likely a particular agent is to commit genocide. And lastly is an agent's radius of sight, which basically determines how many other agents an agent can interact with on a particular generation. But next we have to determine the rules for how these agents will interact with each other. The first way agents will interact with each other is by spreading each other's ideology. Each agent on a particular generation will locate another agent of its same identity with the highest influence in its radius of sight, and it will change its own ideology to be more, depending on its own susceptibility, to be more in line with its most influential agent. So we see how this will mean that influential agents, or the most influential agents, will change other agents in its radius of sight to be more in line with its own ideology. Next, each agent will check its own ideology score and see if it's greater than its threshold to act. If that's the case, it will kill every other agent of opposite identity in its own radius of sight. And lastly, each agent has an equal probability of reproducing in any stage. We'll see that every single stage where agents go through these three things is meant to mimic a generation. So now that we understand this agent-based model, let's look at some results. So it turns out after basically every single run, the agents ended up killing each other. And maybe we think this is not actually an interesting result, but if our starting model and our first experiment is a situation where one group dominates over another group every single time, maybe we can look at ways in which we can change this model such that we can prevent a genocidal outcome. Remember when I went through each agent's attributes earlier? What I didn't mention is that these attributes were randomly initialized on a uniform distribution from 0 to 1, such that most agents were in 0.5 range, but some were higher and some were lower. In this paper's subsequent experiments, what they did is instead for the threshold to act, this was the attribute that determined how likely an agent was to commit genocide. Instead of randomly assigning that as a value from 0 to 1, they set every agent across the population to have the same value, thus calling it the uniform threshold to act. And what these researchers found is that when using a uniform societal level threshold to act, even though the averages ran the same, one group was much less likely to dominate the other. In fact, what they found is that a uniform system threshold level for agent groups had an exponentially beneficial effect in preventing genocidal outcomes. To some, while this may seem like kind of an obvious finding, it's important to note that these computational models were able to validate our intuition, that societal levels of restraint are good at preventing genocide. The next steps here are to define what a societal level of restraint would actually look like in the real world. What would that be? And how can we have policy that would allow us to take real world things and mimic this simulation? The paper, to continue, dives into some real world examples to try and validate the results, and there's many subsequent papers that build off this research and attempt to build more sophisticated models that are closer to the real world and provide us more interesting conclusions. We can get into those later in the video series. However, for the next episode, we're going to be trying corroborate these results using our own model and to try and simulate these results visually so that we can try and get an idea of what's actually happening here. Thanks for watching.